Hello students. So today we are going to start the new chapter on ratios, which is part of your CA Foundation Maths. Let us begin the chapter by looking at some examples. Now, ratio means, what do we mean by ratio? Ratio is the simplest form. Okay, it is the simplest form of representing. Okay, so I'll go through this chapter with the help of some examples. The first question is, find ratio of 100 and 250. Find ratio of 100 and 250. Now the solution, 100 by 250 is equal to, we have to find the simplest form, 2 by 5. This is the ratio. Now let us move on to types of ratios. Let us move on to types of ratios. The first ratio which I'll be teaching you is duplicate ratio. Now what do you mean by duplicate ratio? Duplicate ratio means the square of the original ratio. Duplicate ratio means square of the original ratio. Let us take an example. Find the duplicate ratio of 2 by 5. Find the duplicate ratio of 2 by 5. Let's write the answer. Duplicate ratio of 2 by 5 is equal to 2 square by 5 square. The square of the original ratio is equal to 4 by 25. Now let's move on to the next type of ratio, the triplicate ratio. Triplicate ratio means the cube of the original ratio. One example, find the triplicate ratio of 2 by 5. Solution, triplicate ratio of 2 by 5 is equal to 2 cube by 5 cube is equal to 8 by 125. The next one is sub-duplicate ratio. Now, the sub-duplicate ratio of x by y is equal to square root of x by square root of y. Let us take one example. Find the sub-duplicate ratio of 4 by 25? The answer is square root of 4 by square root of 25, which is 2 by 5. That's the answer. Let's take the next type of ratio. It is the sub-triplicate ratio. Now the sub-triplicate ratio of x by y is equal to cube root of x by cube root of y. Let's take one example. Find sub-triplicate ratio of 8 by 125. The answer is cube of 8 by cube root of 8 by cube root of 125, which is equal to 2 by 5. That's the answer. Please make a note of all this. Let's summarize whatever we have so far learned. We have seen what is a duplicate ratio, that is the square. What is a triplicate ratio? That is a cube. What is a sub-duplicate ratio? That is the square root. We have seen what is a sub-triplicate ratio. That is a cube root. Okay, so you have to be thorough with all these meanings and definitions so that you can answer the questions also, the options given, as well as find the answer to any problems. Let us move on to the next ratio, the inverse ratio. Now, inverse of x by y is equal to y by x. Let's take one example. Find the inverse of 10 by 9. It is 9 by 10. Let's move on to the next ratio, compounded ratios. Compounded ratio means multiplication of ratios. Find compounded ratio of 1 by 2 and 5 by 7. The answer is 1 by 2 into 5 by 7, which is 5 by 14 answer. Inverse, that is the reciprocal. reciprocal of ratio. If it is a by b, it is b by a. If it is x by y, it is y by x. That is the reciprocal. And then we have the compounded ratio, that is the multiplication of find the compounded ratio of duplicate ratio of half, subduplicate ratio of 4 by 9, triplicate ratio of 1 by 3, and inverse ratio of 3 by 4. Find the compounded ratio of duplicate ratio of 1 by 2, subduplicate ratio of 4 by 9, triplicate ratio of 1 by 3, and the inverse of 3 by 4. Let us see the solution. Compounded ratio of means multiplication. So what we should do is duplicate of 1 by 2 into subduplicate of 4 by 9 into triplicate of 1 by 3 into inverse of 3 by 4. This is what we have to find out. So let us substitute the figures here. Duplicate of half, that is equal to 1 by 4 square. Subduplicate of 4 by 9 is equal to 2 by 3. Triplicate of 1 by 3 is 1 by 27 cube root. Cube of 1 by 3. Inverse of 3 by 4 is 4 by 3. So here we have 4 and 4 get cancelled, and then we have 8 by 9 into 27. 8 by 243 is the answer. Now let us take one more question for practice. I'm slightly changing the question here. Find the compounded ratio of 1 by 2, subduplicate ratio of 4 by 9, triplicate of 1 by 3 and 2 by 5. So the first is duplicate. This is a very important question. So please be very careful and Pay attention here. Duplicate ratio of 1 by 2, subduplicate of 4 by 9, triplicate of 1 by 3, all are the same. But here you have to write triplicate ratio of 1 by 3 and 2 by 5. Does it mean it is the triplicate ratio of 2 by 5 also? No. It only means triplicate of 1 by 3 and 2 by 5 means you just don't have to calculate the triplicate here of 2 by 5. It does not say triplicate of 2 by 5. It only says triplicate of 1 by 3 and 2 by 5. So therefore you have to straight away write only 2 by 5. Please be very careful. If you make a mistake here, then you will lose marks very sadly. Okay, duplicate of 1 by 2 is 1 by 4, subduplicate of 4 by 9 is 2 by 3, triplicate of 1 by 3 is 1 by 27 and 2 by 5. Be very careful, only 2 by 5. So that would be 1 by 15 into 27 1 by 405. Now let's take some important concepts here. Okay. Now if you say a ratio of A by B, okay, there can be two situations here. One is A can be greater than B, and the second is A can be less than B. This is greater than B, this is less than B. Now we call this as greater inequality. This is called the greater inequality, and this A less than B is called less inequality. For example, we have 3 by 7. Here in this case, 3 is less than 7, so A is less than B, and this is called the lesser inequality. Less inequality. The next one is if a ratio, let me take an example of say 2 by 5. Now this is an integer. If a ratio is an integer, okay, it's like a perfect number. So in that case we call it commensurable. And if the same, in the case we have another ratio, say square root of 2 by square root of 7, that is a non-integer, we call it incommensurable. So if you were to solve, why do we say it's not a perfect number? When it's a non-integer, it means it's not a perfect number. So if you solve for root 2, you'll get some points, you'll get decimal points. And if you solve for root 7 also, you'll get decimal points. So because of that, we do not say they are integers, and those are called incommensurable. But 2 by 5 is an integer, it's a perfect number, that is commensurable. The third concept which we have to learn is continued ratio. That is when there is a ratio of 3 or more numbers. We call it a continued ratio. For example, we have A is to B is to C. That is 3 or more numbers. That is a continued ratio. Let us take an example to understand the continued ratio better. Okay, I'll give you a very nice example. This is asked in the exams. Okay, this is a beautiful example. So please pay attention very carefully. Don't miss anything here. Now you know that the ratio of A and B, which is A by B, is equal to 2 by 3. and the ratio of B by C, okay, that is equal to 4 by 5. Now you need to find out the ratio of A is to B is to C. How do you find out this ratio? See first here, B here in the case, see between A and B and B and C, the common point here is B. So we have B in both the ratios. But in the first ratio, B value is 3 and in the second ratio, B's value is 4. First, we need to bring this to a common value. Okay, so for doing that, let us observe in the second ratio, B is 4. Okay, so let us multiply the first ratio by 4 and divide it by 4. So then what happens? There is no change to the ratio because this actually is equal to 1. So you're actually multiplying by this ratio, first ratio by 1. But you're saying 4 by 4 into 4 by 4 because 4 is the value of B in the second ratio. Now let us come to the second ratio and multiply that with B's value in the first ratio. We're doing the reverse of that. 4 by 5 into 3 by 3 because this value is also ultimately 1 and that means this ratio, second ratio is not going to change. But we are only multiplying it by B's value in the first ratio so that we bring B to a common value. This is equal to 8 by 12 and this is equal to 12 by 15. Now if you see B here, it is 12 and 12. So B is the common same value. So now A is to B is to C is equal to 8 is to 12 is to 15. It has come to a common point. So that is the ratio of A is to B is to C. This is the answer. Let's take one more example. Ratio of A and B is 3 is to 5. B and C is 2 is to 5. Find the ratio of A, B and C. Very common question. Many times it's asked in the exam, this type of question. So let's take the answer. Ratio of A by B is equal to 3 by 5. Ratio of B by C is equal to 2 by 5. B is the common factor here and B is 5 here and 2 in the second ratio. So let's multiply the first ratio with B value in the second ratio. 3 by 5 into 2 by 2 and the second ratio we will multiply with B value in the first ratio is equal to 5 by 2 by 5 into 5 by 5. This is 6 by 10. This is 10 by 25. So A is to B is to C is equal to 6 is to 10 is to 25. This is the answer. Let us take one example here. Suppose I have a ratio of 10 by 15. Okay, I have a ratio of 10 by 15. Can I simplify this ratio and write it as 2 by 3? Can I simplify this 10 by 15? How do I simplify? I take the common factor which is 5. 5 it can be divided 10 by 5 we get 2 and 15 by 5 we get 3. So 5 ends up being a common factor. Can I write the same ratio as 2 by 3? In that case, what have I done? I have taken out the common factor which is 5. Okay, I have taken out the common factor in both these numbers and I have simplified the ratio. What have I done here? I have eliminated the common factor. I have eliminated the common factor. That's it, right? So if I now want to bring back this ratio to its original ratio. So what is the original ratio? Original ratio is 10 by 15. Original number or ratio you can call it, or you can call it quantity also. that is 10 by 15, and the ratio which I have got after simplification is 2 by 3. If I want to bring this 2 by 3 to the original ratio, original number, I have to multiply it by the common factor. Same common factor which I took out and eliminated, I need to multiply it with the same simplified ratio to get the original ratio. So here there are two things which are important here. The two outcomes which are important here is to find out the ratio. Ratio means simplified form. Eliminate the common factor. The second important thing which is really important from the exam point of view is to find the original number, multiply the ratio with the common factor. Okay, which is a very good question which will give you adequate practice. This is an exam type of question. Now we have two people, X and Y. Okay, their daily earnings is given as 4 is to 5, and the daily expenditure of these two people is 7 by 9, and the daily savings of these two people is rupees 50 each. Now find the income and expenditure. Find the income and expenditure of X and Y. Okay, very beautiful question. Let's take a look at it. Now, when you do the answer, okay, let us first look at the question. Let's observe the question. This 4 is to 5 is a ratio. 7 is to 9 is also a ratio. Rupees 50 each is the quantity, and it is not a ratio, it is a number. Now I know, okay, what did I learn previously? I learned that if I want to get the original quantity, I need to multiply the ratio with the common factor. Okay, so I have a ratio now. This is a simplified version. If I multiply this with the common factor, what I get is the original quantity. Now let us say the common factor for income BP and the common factor for expenditure BQ. For expense BQ. Okay, so let's see the input given in the question. The daily earnings of X and Y are in the ratio of 4 is to 5. Income of X by Y is equal to 4 by 5. We can multiply this by the common factor of for income, which is P, and we get 4P by 5P. Important relationship. The next is expenditure given. Now expenditure of X by Y is given to be 7 by 9. Let us multiply this by the common factor for expenditure, which is Q. Okay, Q by Q. So 7Q by 9q. This is the second most important relationship here. Okay, now we know the relationship of income of x and y in terms of the common factor and expense also. Now let us come to the savings. Okay, you know that whatever income we earn, we have an expenditure against it. Okay, and some of it we save. So income is always equal to expenditure plus savings. Income is equal to expenditure plus savings. So let us see for x, what is the income? The ratio, the input data there is 4p. So we know that 4p, see, let us come to x by y. Okay, we will arrive at a relationship here. That is equal to 4p by 5p. That is the income relation, income equation or the ratio. 4p by 5p is equal to expenditure plus saving. Expenditure of x is to y is 7q. We have to add the saving to the 7q plus 50 divided by 9q plus 50. This is the savings part of it. Expense plus saving. Expense plus saving. This is the relationship. 4 into 9q plus 50 is equal to 5 into 7q plus 50. 36q plus 200 is equal to 35q plus 250. Bring the variables to the left hand side. 36q minus 35q is equal to 250 minus 200. Q is equal to 50. Let us take the first one for x. Okay, for x, income is equal to 4 into p. Expense is equal to 7 into q, which is 7 into 50, which is 350. So income is equal to expense plus savings. 4p is equal to 350 plus 50. 4p is equal to 400. Therefore, my p is equal to 400 by 4, which is 100. We have now found out the value of p and q. P is 100, q is 50. Now what have they asked in the question? They have asked us to find the income and expenditure of x and y. We know that income is equal to expenditure plus savings. And income of x is equal to 4 into p, which is 400. Income of x is equal to 4p, which is 4 into 100, which is 400 rupees. Okay, and income of y is equal to 5 into p, 5 into 100, which is rupees 500. This is the first thing that is asked. The second thing that is asked is expenditure of x and y. Expenditure of x is equal to, come to this side, it is 7 is to 9, 7q. So 7 into, for expenditure of x is 7q, which is 7 into 50, which is rupees 350. And expenditure of y is equal to 9q. Is 9 into 50, rupees 450. This is the answer. Now let's come to the study material, page number 1, 1.1 of the chapter 1, ratio. Okay, unit 1, chapter 1, unit 1, ratio. Come to the first part of that. In the overview, we have been given inverse ratio, types of ratio and ratio. Now under inverse ratio, we have triplicate ratio and duplicate ratio. So in other words, they are just giving you different classifications, different types of ratios. We have inverse, triplicate, subtriplicate, duplicate and subduplicate. All these we have already done. Now we also use ratios in many ways in practical fields. For example, it is given that a certain sum of money is divided into three parts in the given ratio. The first part is given, then we can find out the total amount and the other two parts. These are the applications of ratios. Similarly, ratio of boys and girls will be given in a school and total number of students is also given. Then if we know the number of boys in the school, we can easily find out the number of girls in the school by using these ratios. Let's come down to ratio. I'm going to quickly summarize this. We've already done everything in great detail. It's just a quick summary to help you gain your confidence. A ratio is a comparison of sizes of two or more quantities of the same kind by division. So this is important. Let us note this down. Ratio definition. A ratio is a comparison of the sizes of two or more quantities of the same kind by division. Okay, and suppose we have a ratio of A by B. If I take an example of a ratio A by B, in this the first term A is called the antecedent. It is called the antecedent, and the second term B is called the consequent. Okay, this we need to be able to identify. If we have a ratio of 5 by 6, second example, this is the antecedent. 5 is the antecedent and 6 is the consequent. Both terms of a ratio can be multiplied or divided by the same non-zero number. Usually a ratio is expressed in the simplest form. Let's take illustration 1. Okay, we have a ratio 12 is to 16. We write as 12 by 16. We can also write this as 3 by 4. We can divide this by 4 and we can write this as 3 by 4. Then we'll go on to the next illustration. 3 is to 4 is not the same as 4 is to 3. Okay, and there is no ratio between number of students in a class and the salary of a teacher. Unrelated data or quantities we cannot compare. It has to have some common factor. For example, it has to be of the same kind. Otherwise, we cannot compare it. And it should be in the same unit also. So you have to have either same kind of quantity or same units of the quantity. Now you can find out, for example, illustration 4 given. Ratio between 150 grams and 2 kg. 150 grams is equal to 150 by 1000 kilograms and 2 kilograms. So 150 by 1000. 150 by 1000 divide by 2 by 1. This is equal to 150 by 1000 into 1 by 2. This is 150 by 2000. When you divide a fraction by another number, we will say 150 by 1000 divide by 2. Okay, to find the ratio, it is 150 by 1000 divided by 2 by 1. That is the ratio. We should use the same term 2 by 1. Then we can bring it as a reciprocal 150 by 1000 into 1 by 2. That is 150 by 2000. Sorry, 150 by 2000. We can simplify it as 3 by 40. You can try the example number 5, ratio between 3 kg and 5 kg. Very simple. Then to find which ratio is greater. Illustration 6. To find which ratio is greater. We have 2 and 1 by 3. We have 3 and 1 by 3. And we have 3.6 and we have 4.8. 2 and 1 by 3 is equal to 3 into 2 plus 1. 3 2s are 6 plus 1, 7 by 3. Okay, 7 by 3. 3 and 1 by 3 is 3 into 3 plus 1. 3 3s are 9 plus 1, 10 by 3. Now, they have asked you which ratio is greater. Is it 2 and 1 by 3 is to 3 and 1 by 3, or is it 3.6 is to 4.8? Okay, so we know that 2 and 1 by 3 is 7 by 3 is to 10 by 3. So these will be written like this. 7 by 3 is to 10 by 3, which is also equal to 7 is to 10. We can just drop this by 3 here. This is the first part. Versus we have to find out 3.6 is to 4.8. 3.6 is to 4.8 can be written as 36 by 10 is to 48 by 10. Now this we can write as 36 by 48. Just how we can write this as 7 by 10. Now we have to compare. Now 36 by 48 we can also write, we can divide common factor 4 by this. 9 by 12, again we can divide by 3, which is 3 by 4. Now when you have 3 by 4, we have to compare 7 by 10 versus 3 by 4. So we can write this as 7 into 7 by 10. If you want to get 20, you have to multiply 10 by 2. So 2 by 2, which is 14 by 20 versus 3 by 4. If you want to get 20, you have to multiply by 5. 4 into 5. 3 5s are 15. 15 by 20. So it is going to be 14 versus 15. So what have they asked us now? Which is the greater one? So 15 is greater than 14. Therefore, 15 by 20 is greater than 14 by 20. Therefore, 3.6 is to 4.8 is greater than 2 1 by 3 is to 3 1 by 3. So this is the answer. This is the greater. Next, we have already seen inverse ratio. We have some application questions. And this question is the one which we discussed. Application question number 1, illustration 1. That is going to be very tricky. But please practice that well. You will definitely be tested in the examinations. Okay, I will give you separately for all these illustrations, solved solutions. Solving also I will show you. Let's take a look at question number 2. So we have to do example 2. The ratio of the prices of two houses was 16 is to 23. 2 years later, this is page 1.5 of your study material. 2 years later, when the price of the first has increased by 10%, first house, and that of the second by rupees 477, the ratio of the prices becomes 11 is to 20. Find the original prices of the houses, two houses. So let the original prices be 16x and 23x for the two houses. Okay. So what is the condition given? The ratio of the prices was 16 is to 23. 2 years later, when the price of the first has increased by 10%, so the price of the first one has increased by 10% plus 10 by 100 of 16x. This is the first one. That divide by the ratio of the second, the price of the second. Second was increased by 477. So second one was 23x plus 477. That ratio now has become 11 by 20. So 16x plus 1.6x by 23x plus 477 is equal to 11 by 20. 20 into 16x plus 1.6x is equal to 11 into 23x plus 477. 20 into 16 plus 1.6, which is going to be 17.6x, is equal to 11 into 23 is going to be 11 into 23 is 253 x plus 11 into 477. 52 11 into 477 is 5247. Then we have 20 into 17.6. 20 into 17.6 is 352. X is equal to 253x plus 5247. 352 minus 253 is 99x is equal to 5247. So therefore x is equal to 53. From this we need to find out what are they asking you to find out? They're asking you to find out the prices, original prices of the two houses. So for the first house, house 1, the price is equal to 16 into 53, which is equal to 848. 848. The second house is 23 into 53, which is equal to 1290. This is the answer. Now students, let us do a quick recap before we start the problems. First of all, what is a ratio? What we learned so far is ratios are the comparison of two or more things of the same kind. So for example, x is to y, we can write it as x by y. We can also say it is x is to y. This is how we say it. Okay, so this is the meaning of ratio. Okay, now the numerator x is the first term and the denominator y is the second term. All this we've already done. Just want to do a quick recap so that you are revising it for the second time. Okay, and this is also called the first term is also called the antecedent. And the second term is also called the consequent. Okay, this is antecedent and this is consequent. Second term is the consequent. And they must be of the same units. Ratio as such has no units. Ratio does not have any unit. Okay, so let me go through a few examples, few questions for your practice. Okay, so and some more things which need to be mentioned here are ratio is to be expressed. Again, it is a revision. Ratio is to be expressed in the simplest form. For example, if I say 5 by 25, I need to express it as 1 by 5. Okay. Then order of the terms is important. Order of the terms must be maintained. As in, if I say 1 is to 2 is not equal to 2 is to 1. Okay, so you need to maintain the same order which is given in the question or in the paper. Okay, and the quantities must be of the same kind. I cannot compare apples to oranges. Okay, for example. Okay, then some more things which we saw earlier are if the two terms are x and y and if x is greater than y, then the ratio of x is to y is called of greater inequality. And if x is less than y, if x is less than y, this ratio is called lesser inequality. Another one which we have to see is if x is equal to y, that is called equal equality. That's called equal equality. Again, few more quick revision points. Duplicate, triplicate, subduplicate and subtriplicate. Duplicate is the square. A is to B. Duplicate is A square is to B square. Triplicate is the cube. Okay, A is to B. A cube is to B cube is the triplicate. Subduplicate is the square root. A is to B. Square root of A is to square root of B. Subtriplicate is the cube root. A is to B. Cube root of A is to cube root of B. Then again few more points. Inverse. Inverse of a ratio. Suppose the ratio is x by y. Inverse is y by x. If the terms of the ratio are integers, then the ratio is called commensurable. If the terms of the ratio are non-integer or not integer, then the ratio is called incommensurable. Okay, so an example here is three is to 2, and here example is root 3 is to root 2. This is a non-integer. Okay, now we'll move on to our practice problems. Find the ratio between 150 grams and 2 kg. Ratio required is equal to 150 by 2000. 150 grams by 2000 grams is equal to 150 by 2000 is equal to 3 by 40 is equal to 3 is to 40. This is the answer. Second question. Find the ratio between 25 minutes and 45 seconds. In the first question also, grams and kilograms cannot be compared. That's the reason we are converting grams to kilograms. And in the second question also, minutes and seconds cannot be compared. You have to convert it to one of the common unit. Either you convert to minute or you convert to second. The easiest is to convert the minutes to second. So the ratio which we require is 25. Okay, one more thing. 1 minute is 60 seconds. 25 minutes is equal to 25 into 60 seconds. So 25 into 60 divide by 45. This is the answer. So you need to simplify this. 100 by 3 is equal to 100 is to 3. This is a very important question. The ratio, please pay close attention, the ratio of the number of boys to the number of girls in a school of 720 students is 3:5. If 18 new girls are admitted in the school, find out how many new boys may be admitted so that the ratio of the number of boys to the number of girls may change to 2:3. The ratio of the number of boys to the number of girls in a school of 720 students is 3:5, original ratio. Find out if 18 new girls are admitted in the school, find out how many new boys may be admitted so that the ratio of the number of boys to the number of girls may change to 2:3. The first step is number of boys originally in the school is equal to, now the total number of students is 720. Of these, 3:5 is the ratio of number of boys is to number of girls. So if you want to calculate one particular component, you have to say 3 by 8 into 720. That will give you my number of boys. If I want to calculate the number of boys out of these 720, I have to do 3 by 3 plus 5 into 720, which is going to be 3 by 8 into 720, which will be 8 into 90, 270 boys. 270 boys is the number of boys originally. Okay. Then, so the number of girls, either I find the balancing figure by doing 720 minus 270, that would give me 450 girls, or I can also find out the number of girls by 5 by 8 into 720. These are the two methods in which I can find out the number of girls originally. Okay, till here it is clear. The next part of the question is how many boys, new boys, may be admitted so that the ratio of the boys to girls may change to 2:3. So once, suppose the number of new boys admitted is X. Okay, so number of boys becomes 270 plus X. Similarly, we have to calculate the number of girls also total. But here they've already given you that the number of girls admitted is 18. So number of girls becomes 450 plus 18, which is 468 girls. According to the given question, the ratio has to be 2:3. Okay, the new ratio of boys is to girls is equal to 2:3 is equal to 2 by 3. So what is the total number of boys after the change? It is 270 plus x. What is the total number of girls after the change? It is 468. 270 plus x by 468 is equal to 2 by 3. Solving for x, 3 into 270 plus x is equal to 2 into 468. 810 plus 810 plus 3x is equal to 936. 3x is equal to 936 minus 810. 3x is equal to 126. X is equal to 126 by 3, which is 42. X is equal to 42 boys. Number of new boys admitted is 42.